Okay, let's get started with the second part of section 5.5. This part has to do with factoring by grouping. And in order to do grouping, you have to remember everything that you just learned about common factors. Okay, to do grouping, it allows us to group things so that they have a common factor. So if you're told to factor something like this, and factoring by grouping almost always has 4 terms in it. If you have a polynomial with 4 terms, 1, 2, 3, 4 terms, and you're asked to factor it, first check for common factors, and you'll notice that there's nothing in common to everything here. These two have x, these two have y, these two have 5s. Okay, so there's nothing that everything has. So common factors for all these don't exist. But when you have 4 terms, you can use a method called factoring by grouping. So of course, we're going to group these so that we can do a factor with a common factor. This one is in a good form, just the way it is. If I group the first 2 together, and plus, I group the second 2 together, then I have a common factor in this first group. What is that common factor? What's the greatest common factor of these? What's the largest thing that divides them both? Yes, y. So factor out that y, and I get an x plus 1, right? Because that gives us the right thing when we multiply back. So I took out the common factor in this group. And in this second group, let's think of it separately. In the second group, what is common? What's the greatest common thing? Only the 5. So I pull the 5 out, and it leaves an x plus, divide the 5 out, 1. Now by doing this grouping, I now have 2 terms. But look at those. The good news is they have a common factor, and that's the last example I believe that we did in last, where we had 2 terms with an ugly looking factor like this. So these have the common factor of x plus 1. So now what I'm essentially doing is I'm going to take this part and factor it out of those. And when I take it out, what's left? The y is left, and I take this out, and I have the 5 left. So this is the answer in factored form. Okay? That is what you're looking for. But I want to show you something. If you multiply this through using distributive property, we get xy plus 5x plus 1y plus 5. Notice that we're back to where we were. We had an xy, we had a 5x, a 1y, and a 5. So what we've done is we've factored it down. And you can check your factoring by multiplying it out. Okay? Okay, that's called factoring by grouping, because in order to group factor them, we must group them. Okay? Let's do another one of these. Let's do 3b. It's a little trickier because it has negative signs in it. I'm writing a 3, but there's no 3. It's a 2. 2y minus 12 minus xy plus 6x. Okay. We can try grouping these just the way they are. Why do I group? Because if I look at these, is there anything common to everything? This doesn't have a number, except for 1. So no number divides everything. There isn't an x in all the terms, or a y in all the terms. The only hope is to group them so that we have common terms. So I group the first 2, and I group the second 2. Okay? Notice that I put that negative inside because I can easily make a sign mistake otherwise. So I said this is the first group and this is the second group. I kept the negative with the term that it belongs with. In this first group, what is common? Yes, the 2. Pull out a 2 and you get y minus 6. What in the second group is common? Just the x. So let's take out the x. And that gives me a minus y plus 6. These aren't exactly the same, are they? We have a positive y and a minus y, and a negative 6 and a positive 6. And these two things, if we were in luck, they would have the same factor in parentheses there, and they're not the same. They're off by a negative sign. So what I'm going to do is I'm actually going to take the negative sign out of that second one too. Then I'll show you another way to do it to avoid this if you don't like that. I'm going to pull the negative sign out, divide out a negative. If I divide the negative out of here, it makes it positive y. And that would be a negative 6, because the negative times the negative would get us back to the positive. A positive divided by a negative is a negative. So we had to switch the sign. In other words, it's like minus a negative, same as adding. Okay. Now the reason I did that is that now this piece and this piece have a common y minus 6. I'll pull that out. There it goes, pulling it out. And what's left? The 2 minus the x. Okay? Now, let me show you another way you can do this if you didn't like that, which I know some of you didn't. The problem was that this one had a negative and that one had a negative, and the negatives were in a different place. Okay? So let's take this exact same problem and show you an alternate way to do it. Okay. I'm going to put the 2y plus 6x at the beginning. That's not going to help me. I thought I would make it easier for you, but I don't think I see an easy way to fix it. No, I think that this isn't going to work. I was going to try grouping this and taking out a 2. I think it's going to all boil down to the same trick at the end. Okay, sorry about that. I can't show you a different way to work that that's going to make it any easier. We can do the same thing, but it will be equivalent to what we just did. Okay, let's look at 3c, which also has a negative sign. In fact, it's actually kind of different from what we just did, so I'm glad we're doing it. Okay, first of all, are there any common factors to all 4 terms? No. No number divides all the numbers, and no variable is all the way through it, so there's no common factor. If that's the case and we have 4 terms, we do grouping. Almost always this book allows you to group the first 2 together, and that will not be the case in college algebra, but it is the case in algebra 2. So, now in the first group, what is common? Only the x. So I take out the x and it leaves me a y plus a 9. Notice these both have negatives, so I'm going to take the negative out because this doesn't have a negative, so I want them to look alike. And I can also factor out a 7. And that leaves me, divide a negative 7 out, and it leaves me a y. Divide a negative 7 out, it leaves me a positive 9. Aha, that's good news because these 2 pieces both have a y plus 9 in them. Okay, when I take out the y plus 9, I factor it out, right? What's left? An x minus a 7. Okay, so if you multiplied that back out, it would get you to where we started. And that was 3c. Let me grab some more paper here. And we'll be taking on to 3d. Now, factoring by grouping takes some getting used to. It is important. It will come up, and you've got to learn it. So just do a lot of practice. That's the way to learn math. Okay, here's 3d. It would be a good idea to stop the video and try this on your own, and then check it and see if you really have down factoring by grouping. Okay, let's go ahead and do this. I'm going to group the first 2 and see if that works. If it doesn't, you can always try grouping other ones. And then the second 2. Okay, the first group has a common 5 and a common x, which I divide that out, it leaves me a y minus a 2. And the second group has a common 7. Pull the 7 out, and that leaves me a y minus a 2. Here are my two pieces. Notice that they have the same common thing, right? So I'm going to pull that out. When I pull it out, what's left here? A 5x and a 7. Okay? So that's the factored form. If you multiply this out using FOIL or just multiplication, the same thing, it would get you back to where we started. Very good. So that is factoring by grouping. Now in the next few problems, they don't tell us how to factor them. They just say factor. And so we remember that the first thing we should always check for is a common factor. So let's look at number 4a, which says to factor 16x to the third minus 12x. Always check first for a common factor. What's the largest number that will divide 16 and 12? 4 is correct. Okay, so 4 will come out. And notice they both have the variable x, so take the lowest power of x, and this is our common factor, 4x. That's the greatest common factor. Divide it out. 16 divided by 4 is 4. X cubed divided out, and x leaves x squared. 12 divided by 4 would be negative 3. X, we pull that x out, nothing there. Okay, and this is the difference of not perfect squares. So they've given us things that will not factor again. So that would be the answer on part A. Part B says, look at negative 27x y cubed plus 18x to the fourth y. Okay, what is the largest number that will divide negative 27 and 18? 9. Okay, so we're going to divide a 9 out. Now we have x in both of these terms, so we choose the lowest power, that would be x to the first. We have a y in both terms, we choose the lowest power of y, that would be y to the first. And we divide. Negative 27 divided by 9 is negative 3. X divided out, we had y to the third, we divided out one of the y's, leaving a y squared. And then 18 divided by 9 is 2. Y x to the fourth divided by x is x third. Y divided by y is 1. Okay, so that is the lovely answer. Very well, and let's see if we can fit C down here. 9y z plus 2. And oops, that should be a minus. Minus 4z plus 2. Okay, we have this term and this term. They're being subtracted. Two terms. They're ugly, but they're subtracted. They have a common factor. So this is already sort of partway through factoring by grouping. They have a common factor of z plus 2. So when I take this one and I divide out the z plus 2, it leaves me a 9y. I take this one and I divide out the z plus 2, and it leaves me the negative 4. Good. All right. Let's do part D. 9y. That's the one I just did, isn't it? Did I call it D before? Yeah. For A, B, C. And numbered it wrong. Right. So the one I just did was actually D. Right, that was D. Oh well. Let's do the real C now. The real C on number 4. 8. A to the second, B to the second, C minus 12a b to the second c minus 8ac plus 6a. Maybe there's a reason I did not do that one yet. Very well. Okay, is there a common factor to all of these? Yes. There is a common 2 and a common a. But I'm suspicious, since these first two have a, b, and c in them, that we could do a little more factoring by taking this into grouping. So I'm going to group it because it looks like there's more factoring that would work that way. And then I'm going to rearrange these so that I have the positive one first. I don't know if it's going to help me or not, but it might. You never know. So I just put the 6a first when I wrote it down, and then the 8a last. Okay, the common stuff here. They can have a common 4, a to the first, b to the second, and c. So I looked through and I took the lowest power of everything they had in common and got the number. That leaves a 2, another a's there, the rest is gone. 12 divided by 4, negative 3. We took out the a, took out the b's, took out the c. Okay. And then, what do these have in common? 2 and an a. That gives me a 3 minus 4c. This doesn't look too good, does it? Sometimes that happens. So let's see if we have another way to do it. We did observe that didn't work, okay? How did we know it didn't work? Because these are not common. We can't take out a common factor if they're not the same, okay? So let's go back to the original one and let's work with our observation that we knew everything could be common too. And I said you should take out the common factor first, so we'll try it this way. 2 will go into everything. That's the largest divisor. And they all have a's in them. So 2a is the greatest common divisor, or factor. And let's see what's left. That gives us a 4ab squared c minus a 6b squared c minus a 4c plus a 3. Okay. And now we notice that no matter how we group these, there isn't going to be anything in common in both groups. We could group these together, but there wouldn't be anything in common in those. And when we factored this, it wouldn't look like that. It's not going to ever go any farther, is what I'm trying to say. These don't have anything in common. We group these together, but that's as far as it's going to go. Okay? So all there is a common factor. It deceived us into thinking that it could work with grouping, but it didn't do it. Okay? And that was C. Let's go ahead with D. We did D already. We did D before C. Now let's look at E. Okay, E says to take 4xy minus 8x plus 7y minus 14. Is there anything common to everything? No common factor. So we have no option here but grouping. So I'm going to begin by grouping the first two and grouping the second two and hoping it works. In the first group I can take out a 4x. And that leaves me a y minus a 2. In the second group, I'm going to take out a 7, and that leaves me a y minus a 2. Hey, this is good news. Those both have a y minus 2 common factor. I will pull the common factor out, and it leaves a 4x and a 7. So we have completely factored that using grouping, which was nice. Okay, and the final example today on this section is x cubed, wait, let me see if that is a cube. X cubed, yes, plus 5x squared plus x plus 5. Well, there's nothing common, no common factor, no greatest common factor here for every term. So we just try the old tried and true grouping. When we have 4 terms, try grouping. In the first section, we could take an x squared out. If we take out an x squared as the greatest common factor, we have an x plus 5. In this group, there's nothing to take out. But it doesn't bother me because I notice that this piece and this piece both have the x plus 5 in them. So if I factor out that x plus 5, it leaves an x squared here. And when I divide anything by the same thing, I get a 1. So this is the answer in factored form for that last one. Okay, this concludes section 5.5. Please make sure that you're keeping up with your My Math Lab as we go along, and I will see you later for the next section. Email me if you have any questions.